system, crossing the interstellar void to enter our solar neighborhood. That object is 3A Atlas, an extraordinary visitor that has not only captured the attention of astronomers around the world, but is also challenging what we think we know about comets and interstellar visitors. In the next few minutes, we're going to dive into its origins, how it's made, its orbits, and its strange behavior. And I'm also going to show you one of the most incredible theories surrounding it. And finally, what we already know for sure so far. Brace yourself because what this object can tell us could change the way we see the universe. The journey of 3I Atlas began long before we detected it. Its starting point lies outside our solar system, making it only the third known object with an interesting origin to enter our system. It was identified on July 1, 2025 by the Asteroid Terrestrial Impact La Solar System (ATLAS) network of telescopes in Chile, after which astronomers realized that its trajectory was not tied to the Sun, that is, it comes from outside and will eventually leave. From that moment, intensive monitoring began. Observatories like the Hubble Space Telescope capture images that allow scientists to estimate that the solid part of this comet, the nucleus, has a maximum estimated diameter of about 5.6 kilometers, although it could be much smaller. The importance of its discovery lies in the fact that objects like these are unique windows into other star systems, allowing us to study materials that form under conditions different from those of our solar system. When scientists began studying 3I Atlas, they discovered it was no ordinary comet. For example, its coma, the cloud of gas and dust surrounding it, is becoming active even though it is still farther away than is typical for a comet in our solar system to become active. This suggests that its composition and structure are different. It has also been observed releasing jets of gas and dust toward the Sun, which is partly normal for comets, but combined with its origins and speed, it adds intriguing nuances. An image taken on August 2nd by the TTT telescope in the Canary Islands showed a jet extending thousands of kilometers from the comet's nucleus. Another interesting fact about 3I Atlas may be changing color as it approaches the Sun. Observations indicate an emerging greenish hue, probably due to certain gases such as cyanide or carbon becoming more active in the Sun heats. And one more thing, its chemical composition differs from most of the comets we know. It has a much higher carbon dioxide to water ratio than usual, indicating that it came from a different environment than comets formed in our solar system. Now I'm going to explain you about its orbit, because the trajectory of 3I Atlas is hyperbolic, meaning it is not gravitationally trapped by the Sun, and after its passage will continue its journey into deep space. It is expected to reach perihelion, its closest point to the Sun, in late October 2025, approximately 1.4 astronomical units from the Sun. What's strange here is how it's moving. Its entry speed is unusually high, and its direction comes from a region of the sky and an angle that doesn't fit the flow that astronomers expected for interstellar objects entering our neighborhood. This factor adds to the mystery, the why and the how of its arrival. Furthermore, its tail is developing faster than expected, and new images show that it's growing in size and activity, as if it were waking up as it approaches the Sun. Now I'm going to tell you about some theories that some astronomers have linked to 3I Atlas, but this doesn't mean it's real. They are just theories, and besides, I don't really believe in them, but I'm going to mention them because I found them interesting. One of the most discussed theories is that 3I Atlas might not be just a natural comet, but an artifact or artificial origin, or at least an object that underwent processes we don't fully understand. Astronomer A.V. Loeb has suggested that given its speed, trajectory, and some of its chemical peculiarities, it could be something more engineered that simply ripped from a star system at random. Another interesting theory is that its high CO2 to water ratio indicates it formed in a very different environment, perhaps more irradiated or cooler, which challenges our idea of a typical comet. This, in turn, raises questions about just how diverse the material circulating through the galaxy can be. And the mystery, where exactly did it come from? Simulations suggest it could have originated from the Milky Way's big disk, implying that it's a very old object, ejecting long ago from another star system, but determining its parent star or its exact trajectory is nearly impossible with current data. Although many ideas are speculative, what has been confirmed is that Tri-Atlas is active, is releasing material, and its comet tail are growing, confirming its cometary nature. It has also been established that it poses no threat to Earth, which is safe for us. We have estimated its size to some extent. Hubble images have allowed us to adjust the limits of the solid nucleus to the maximum of 5.6 km in diameter, although the uncertainty remains large. And finally, thanks to continuous observations, Tri-Atlas is no longer just another comet. It is a mobile cosmic laboratory. It gives us the opportunity to directly study material that form outside our solar system, which means that what we learn from it could be applied to understanding how star systems form, how objects are ejected into interstellar space, and how common these visitors are in our galaxy.